Alright, so today we're doing hyperbolas, which is 12.4, section 12.4. Today's objectives are to use the distance formula to find the constant sum, write the equation of a hyperbola, and to graph the hyperbola. Alright, and you'll notice that these are the same objectives almost that we had last time when we did ellipses. And we're going to have a very, very similar lesson to our last lesson, which is where we did the ellipses. Okay, so hyperbola and ellipses are going to work very similar. The first thing we'll cover is using the distance formula. Okay, so we'll come over here using the distance. Oops, let me go back to the heading. We're using the distance formula to find the constant sum of a hyperbola. Okay, so just like we did with ellipses. Now, when I did this with ellipses, you'll notice that a slight difference in my formula. We're still using the distance formula. The difference is that when I did this with ellipses, I added my two distance formulas, whereas with hyperbolas, I'm going to subtract. All right, so you'll see it says distance d equals, those are absolute value signs. Okay, those are important. The absolute value between the point for the focus 1 minus the point to focus 2. So now it doesn't matter what order I put them in. So we're going to say distance equals square root minus square root. Well, focus 1. Well, focus 1 is this one. So I'm going to say, all right, my point is 4 minus negative 5 squared minus, plus 0. I have no idea what that is. There we go. 0 minus 0 squared. Okay. And over here, I'm going to use my second focus point, which is going to be 4 minus 5 squared plus 0 minus 0 squared. Well, 4 minus negative 5 is the same thing as 4 plus 5. 4 plus 5 is 9. So I have 9 squared plus 0 squared. Of course, square root. Minus 4 minus 5 is 1 squared plus 0 squared. And of course, the zeros just go away. I don't really need those. So I have 9 squared, and then I'm taking the square root. Well, I know that my square root and my square cancel out. I'm just going to make sure that number's positive. Well, number's already positive, so 9 squared is 81. Square root it, I get back to 9 minus 1 squared is 1, square root back to 1. So I get 9 minus 1, which is 8. So my constant sum for this one would be 8. Next, we're going to talk about how to write the equation of a hyperbola. Okay, how to write the equation. And to do this, we're first going to look at our graphs and our charts on kind of the anatomy of a hyperbola. So, right here. So here's my graphs. Notice they're using a lot of the same notation. We're using vertex, covertex, and focus, and we use A, B, and C, just like we did with the ellipses. We use horizontal and vertical, and just like with the ellipses, my vertex and focus are in the X spot when it's horizontal, and they're in the Y spot when it's vertical, and of course covertex is always opposite. A difference is that little box, because notice the covertex isn't actually on the hyperbola. It's just at the top of that little imaginary box. Well, that box gives me, see those diagonals coming through the box? Those give me my asymptotes. See the word asymptote there. Okay, we've studied those. It's a line that my graph gets closer and closer to, but never actually touches. So that's the purpose of my covertex. There's those two graphs. If I come down here, it says my equation. Well, notice my equation looks almost just like the equation of my ellipses. The only difference is instead of using the plus sign, we're using a minus sign. Okay? Now, another difference is that with the ellipse, the a, I can always tell the a from the b because the a is the larger number. With hyperbolas, the a is not necessarily larger than the b, but I can still distinguish it because the a is always going to be first. Okay, whereas with the ellipses, I could switch the terms around because it was addition. Since hyperbolas use subtraction, I can't just switch the terms around. That changes things. For instance, 3 plus 2 is the same thing as 2 plus 3, but 3 minus 2 is not the same thing as 2 minus 3. Okay, so with subtraction, order does matter. So my a is always going to be the denominator of the first term, b is going to be the denominator of the second term, and I can determine whether it's vertical or horizontal by which variable comes first. If the x comes first, it's horizontal. If the y comes first, it's vertical. Vertices, the foci, and the co-vertices are going to look pretty much the same. The only difference is they're adding this little thing called the asymptotes. Well, the asymptotes are plus or minus b over a times x. Well, b over a gives you the slope of the line times x. Okay, so we're adding that little thing there. Now, for our purposes right now, what we're trying to find is the equation. So for the equation right now, all I need is a and b. So let's look at a question. It says, all right, write an equation in standard form for each hyperbola. Well, I'm looking at this and I see, okay, well, if I go back to my graphs, I see it's a horizontal one. So horizontal is x squared over a squared minus y squared over b squared equals 1. So okay, so we have our equations there. We said it was x squared over a squared minus y squared over b squared plus, equals 1. Okay, so I need to figure out, well, what is my a and what is my b? Well, if I'm going to look very carefully, I see that my little hash marks are going by 2 because this one right here is 2, because this one right here is 4, has a 4 on it. So we're going by 2s. Well, my vertex, the point here and here, well, I see if I go 2, 4, 6, it's halfway in between 4 and 6. So my a, halfway between 4 and 6, has to be 5. Whereas my co-vertex, which would be here and here, would be 2, 4, it's halfway between 2 and 4, so the b has to be 3. It's halfway between 2 and 4. So on my equation, I have x squared over, well, 5 squared minus y squared over 3 squared equals 1, which is x squared over 25 minus y squared over 9. And that's my equation for a hyperbola for this problem. Okay, so our next one, we don't have a picture for this one, but they give us the vertex and the focus. All right, so we have center at 0, 0. My vertex, well, I know that 12 is my A, focus is my C. Well, I need to find my co-vertex. Well, when I had ellipses, we used C squared equals A squared minus B squared, okay? However, However, ours are going to have c squared equals a squared plus b squared.
Dylan Morris, please report to the front office. Dylan Morris to the front office.
Okay, so we're going to use c squared equals a squared plus b squared. Okay, so the sign's opposite with the hyperbola. Well, I know my c squared is 20. A is 12. Okay, so 20 squared should be 400 equals 144 plus b squared. I'm going to subtract 144 from both sides. And go 256. If I do a square root of 256, I get 16. So b equals 16. Okay? But remember, I really don't care what b equals. I'm really only concerned about the b squared. Okay? So I'm going to end up with, first, is it vertical or horizontal? Well, I look at my vertex. My A is in the y location, so it means it is, in fact, vertical. So I'm going to have y squared over a squared minus x squared over b squared equals 1. So my a squared is going to be 144, so y squared over 144 minus x squared over, well, b squared is 256 equals 1. So again, here's an example where my b was actually larger than my a, and that's okay. That rhymes. All right, and so there's my equation of the hyperbola. Here are two problems. You see the 2A and the 2B. Go ahead and try those real quick, and while you're trying them, pause the video because I'm just about to put the answers to both of those on the screen. So pause the video now, attempt 2A and 2B, and then you can hit play and you'll see the answers on the screen. Alright, so for 2A, you should have gotten y squared over 81 minus x squared over 49 equals 1, because the vertex is in the y location, so vertex goes to the x. For 2B, you should have gotten x squared, because the vertex is in the x, it's horizontal, over 81, sorry, no, my fault, over 64, 8 squared, 64, minus y squared over 36 equals 1. Now, some of you may have put 100 there because you saw, oh, 10 squared is 100. But remember, this is my focus. So we had to use the c squared equals a squared plus b squared, okay, in order to find out the covertex, okay? All right, and lastly, we're going to talk about graphing hyperbolas. Well, and just like last time with ellipses, we're going to introduce, well, what about cases that do not have a center at the origin? Well, we have this chart. So you would probably want to go ahead and write this one down in your notes, just like we did with our ellipses. Okay, so write this one down, put it in your notes, because we're going to refer back to this as we are graphing these hyperbolas. Okay, but again, you'll notice this chart looks pretty much just like the ellipse chart. Difference again is the equations, minus signs instead of plus signs, and of course we have the asymptotes at the bottom. So it says find the vertices, covertices, and asymptotes of each hyperbola, and then graph. Okay, so we're going to refer back and forth to our chart on this one. Alright, so vertices, covertices, and asymptotes. Well, first, notice that this one is actually centered at the origin. So my center is 0, 0. So I will be using the first chart on this one. Okay. I see the A equals, not 25, sorry. The A equals the square root of 25, which is 5. B equals the square root of 36, which is 6. Okay. And then my asymptotes are y equals, now this one is vertical because the y is first, so because it's vertical I have plus or minus a over b x, plus or minus. So that means I have y equals positive plus or minus 5 over 6 times x. So go ahead and draw my lines. My cheat so I can draw a little last line. Okay, so there's my axis. Well, I need to graph these asymptotes real quick. So I see, all right, plus or minus 5 over 6x. So if it's positive, that means I'm going to go to the right and up. So I'm going to start at 1, 2, 3, 4, 5. And then up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm also going to plot the A and the B, my vertex and covertex. So I have my vertex, which is my y value, at 5. Now, put my axis in the wrong way. I shouldn't have 6 going on the y x direction. 5 on the y. So 1, 2, 3, 4, 5 in the y direction. 1, 2, 3, 4, 5, 6 in the x. All right, and I'm going to make my imaginary box. Okay, there's my imaginary box. In my imaginary box, I'm going to connect the pointers. Same thing over here. Okay. Hopefully you have a rule or something to make the line so straighter than mine. I see that it's vertical, so I'm going to start my line at points here and here. And then my hyperbolas is just going to come out. It's going to get closer and closer and closer to that line, but never actually touch it. Okay. Get that popped a little bit. So there's my hyperbola. I got the asymptotes, which are my dotted horizontal lines, my A and B, which led me to graph the actual hyperbola. Okay. Well, now what if I have one that is not at the origin? So we have like this one. Okay, so first let's figure out where's the center of the H and K. So I know H, K, max and Y. Well, my H is going to be positive 2, my K is going to be negative 3. So there's my center. I know that because the X is first, we have a horizontal graph. So again, going back to that table, we're supposed to have copied down my correct form for my equation. So I see that one there. My vertices are H plus minus A, comma K. My foci are H plus or minus C, comma K. And my co-vertices are H, comma K plus or minus, and then the B. And then lastly, my asymptotes will be Y minus K equals plus or minus B over A X minus H. And that's point slope form. Okay. Now if I read the instructions, it says find the vertices, co-vertices, and asymptotes. Doesn't say find the focus. So I'm going to cross focus off my list. It's not one of the things I need to do for this problem. So my vertices. Well, I see I have my H, which is 2, plus or minus. My A, well, the A is the square root of what's under the X. So I know A has to equal 4, and the square root of 49 is the B, so B has to equal 7. So I'm going to have 2 plus or minus 4, comma, and then my K is negative 3. So that means I have 2 plus 4, which is 6, comma, negative 3, and then 2 minus 4, which is negative 2, comma, negative 3. Come down to my co-vertices. I have H, which is 2. I have my K. K is negative 3 plus or minus. B is 7. Equals, well, 2, comma, negative 3 plus 7 is 4. And 2, comma, negative 3 minus 7 is negative 10. Okay, negative 10. And then lastly, my asymptotes are at y minus, well, the k is negative 3, so plus 3 equals plus or minus, my b is 7, so 7 over 4. It's minus 200. There's my asymptote. Okay, so I found the vertices, co-vertices, and the asymptote. Now let's actually graph this. Alright, so first I'm going to plot my vertices points and my co-vertices points. So my vertices are at, well, let's do my values. So we have 1, 2, 3, 4, 5, 6, and 1, negative 2. And then the y values for both of those is at negative 3. So I'm at 6, 1, 2, 3, so right here. And then I'm at negative 2, negative 3, so here and here. Whereas my co-vertices are at x values of 2, and then a y value of 1, 2, 3, 4, here. And then a y value of negative 10, so it's negative 3, 4, 5, 6, 7, 8, 9, 10. Okay? And I can see, well, I can use this to form my imaginary box. Okay, well, if I join the corners of my box, and of course my center is at 2, negative 3, which is right there, so it should go through that center. Just kind of keep them going off. And then come this way, start at the center. Start at the center. Okay. Now, this one is a horizontal, so starting at the left and the right point, so right here, go off to the side. And that is a curve. It's just curving along. I didn't do a very good job drawing that one. I'll try to draw this a little better. Okay. I didn't draw this well. Let's try that back. Again. That's a little better. Okay. And that's what it should look like. And there's one, of course, in your book that kind of shows you probably a little better picture than what I drew. Basically the same thing though, okay? And that's how we do our items with hyperbolas. So, homework is problems 1 through 29 on page 842. If you have any questions on that one, you can send me an email. Otherwise, have a great weekend. Thanks.